Hey guys, I have been applying to college, so I have not uploaded recently, but now I'm back. So what I want to go over in this video is the discriminant and how you can use it to determine if an equation has real or complex solutions. So first of all, we need to determine what a complex solution is. Remember that when we're talking about complex numbers, we are playing with this number right here, I, okay? And we define I to be square root of -1. You know that you cannot exactly find any value for square root of -1, but, well, in mathematics, you can say that this number is simply the letter I, okay? When you have to deal with a weird square root that has a negative inside, this is what we call a complex number, okay? Now, in the quadratic formula, you can see that we only have one square root, okay? So if you really want to reason how is it possible for you to get a complex number inside this quadratic formula, or somehow make x be equal to a complex number, the only possible way in which that can happen is if this square root has a negative number inside, okay? Because think about it, the only way you can get a complex number is if you have a square root of negative something. And the only way you have, the only square root that you even have is this one right here. And the only way in which you can make this square root be negative is if you get b squared minus 4ac, let me write it, if b squared minus 4ac, this is the famous discriminant, is less than 0. That is, it is negative. So if this is negative, then we say that any equation that you have has complex solutions. Okay, it's that simple. Now let me give you an example to show you all of this more precisely. So say we have the following equation. If we have x squared minus 4x plus 5, and this equals 0, how do you solve for x? Well, of course, you can use the quadratic formula. So we're going to go x is going to be minus b. We know b is equal to -4, so minus minus, that is plus. So we have 4 plus or minus the square root of b squared minus 4ac, the discriminant. So we have -4 squared, that is 16, minus 4a, that is going to be 1, c, that is going to be 20. And 2a, a equals 1, so it's just 2. Now you can simplify this into 2 plus the square root of -4 over 2. Now here comes the fun. You can see that inside the square root, which is the same scenario that I explained up here before, inside the square root we have a negative number. So that means that no matter what happened before we got to this part, we need to use a complex number to solve this expression, or to find x basically. And if we need to use a complex number, remember that we don't have any real solutions. So what is the solution to this equation? Well, we know that if we have that, I'm gonna write it again, plus square root -4 over 2. Now, if you want to find this square root, you're going to do the following. You're going to grab the number that you see inside the square root, which is 4, and you're going to write whatever that square root is. Square root 4, we know is 2, so you're going to write the 2. And to account for the negative sign that you have right there, you're going to write I, okay? Or square root -1. If you square this, you're going to have 2 squared, that is 4, and I is equal to square root -1. So if you have square root -1 squared, that is going to be -1. And -1 times 2, that's times 4, I'm sorry, this is gonna give you back this, okay? So now, these are the two solutions that we have for x. And you can see that no matter what, if you write 2 plus 2i or 2 minus 2i, both of these solutions use complex numbers. Both of them use I, and that is because the discriminant, the number that is inside the square root, was less than 0. If you simply graph, you can see it here. We have b squared is 16, minus 4ac is going to be -20. And that is simply going to give you -4. So this part, b squared minus 4ac, is going to be less than 0. So it has complex solutions and no real solutions. This is how you can use the discriminant to find if an equation has complex or real solutions, okay? It is very simple, and I hope you understood all of this and learned something. So yeah, that's all. See ya.